Hello everyone, it's Aaron Breimer with Veritas Farm Business Management. If you've watched some of our other videos or presentations, you may recognize this slide. I've used it before to talk about how good decisions can be made in agriculture. A combination of gut instinct, past experience, and more recently, precision ag data. When you're able to balance all three, better decisions can be made. I share this with you today because we've developed a new tool here at Veritas that takes gut instinct, past experience, data, and allows you to get better insights from your soil test data. Yes, soil test data. So, there's some basic methodology in soil testing. You can have your bulk samples, one sample every 25 acres in Ontario, one sample maybe all the way up to one sample every 160 acres in Western Canada. In the 1990s, grid sampling was all the rage. You took a whole bunch of samples, you fed it into a computer, it created a map that was supposed to reflect what was going on in your field. Farmers said, it's not always as accurate as we would like, so we started to get into zone sampling. Drawing predetermined zones, sampling those, and creating maps from them. So you can see we've got the two cases. We've got the smaller field up above, which in this case is 40 acres, and below is our hypothetical field. Now, the latest thing that we're starting to see in the soil testing world is what we call soil sensing equipment. There's a lot of different systems on the market. Not going to talk about each one. Actually, not going to talk about any of them. They all have one thing in common. They collect a massive amount of data, and it allows you to get very good resolution of your field. In fact, I suspect with that kind of resolution, you're starting to see the pattern. Now, there's the actual field and the work of art. Okay, you might be asking, well, which one's right for you? That's not what the point of this video is. We do have another video around capturing variability. I encourage you to have a look at it if you're curious as to which system is right for you. We've been able to figure out how to quantify capturing variability. Really cool video. Check it out. Now, you get your soil test back. So what? How much fertilizer do you actually need? Well, there's a pile of different ways, a pile of different opinions on how to read a soil test. What it all comes down to is this idea of what is the limiting factor. This goes all the way back to 1873. We call it Liebig's Law of the Minimum. You guys have seen this before. It is the barrel, the staves are at different heights, the water pours out whichever stave is the lowest. Okay, we get it. The challenge is, which is that lowest stave? The example I like to use, and I'll challenge agronomists with this. If you got a soil test back, and the pH was 5.9, the phosphorus is 11 parts per million, and the potash is 76 parts per million, and you're going to be allowed to fix one. Which one do you want to fix first? A lot of agronomists right now are saying it's pH. Really? You didn't even ask what crop it was. You didn't ask if it was a clay or a sand. And right away you jump to pH. I'm thinking that if I had a clay ground and I had corn going into that field, and I only had 11 parts per million of phosphorus, that would be the one I'd be fixing first. So, this comes back to that gut instinct, past experience, right? Wouldn't it be a cool idea if we could combine data with those first two, that gut instinct, that past experience, to make better recommendations? That's what this tool is designed to do. So what we've done is we've taken soil test data. It can be bulk, not ideal, but bulk will work on our tool. It can be grid, it can be zone, it can be that intensive soil sensing technology that collects a pile of data. And what we do is we take your yield data. Yes, the yield data that comes out of your combine. That yield data that draws really pretty maps. But what else do you really get to do with it? Well, maybe you get to look at how different varieties perform. But what we do is we overlay those two. And we start looking for what we call the response curves. So here, you can see how the potash is changing based off of this CEC. And what we're actually looking at is the effect of the potash on yield by CEC. For those of you not familiar with CEC, that's cation exchange capacity. It's a okay way, I guess, of being able to see if you've got a really heavy soil or really sandy soil. The lower the number on the CEC, the sandier your soil. So there's the example of potash. Here is the example of phosphorus, so bicarb, and how that has a different impact. Now, what we are able to do with our tool, and some people would call it an algorithm. Now, quick note about algorithms. Algorithms are a great way to confuse people. If you say algorithms, everybody gets scared and says, oh, I don't know if I want to ask any deep questions. So we're not going to really use the term algorithm. This is a tool for you. And this tool, we actually call it soil. Statistically obtained ideal levels. It uses your soil test data, your yield data. And what we create is we create these soil limiting maps. So in any part of your field, you know what is the number one soil limiting factor. This is the factor that is limiting your yield. Maybe it's pH. Maybe I'm wrong. Maybe it's phosphorus. Maybe it's potash, depending on which crop. Now, soil limiting 1, pretty cool. But we're also able to create soil limiting 2 and soil limiting 3. I thought these maps were awesome when I first seen them. However, a lot of people have said there's a lot of color there and they're very confusing. All right, let's see if we can find an easier way to do it. So what we did was we combined all three. So here's the second set of soil maps. Remember, statistically obtained ideal levels. This map shows where bicarb phosphorus is limiting on that field in one of the top three, either soil limiting 1, 2, or 3. Where it's green, phosphorus is not a limiting factor. Where it's red, it is. This tool goes one step further, and if it's excessive, another color will pop up and say you've got too much phosphorus in that area. Here's the example of potash. Once again, where it's green, it is not limiting. Where it is red, it is. Now, these are just two. We give you a full set. If you're testing for phosphorus, potash, boron, magnesium, copper, whatever you're testing, we will put into this tool. We will use your yield data, like I said, your soil data, and it's going to come back with a set of these maps in order for you to be able to understand what is limiting your yields. Yes, Mother Nature always wins, but fertility is described as the next best thing to rain. So, this is a great tool. We would really encourage you to get in touch with us if you want to test this out for yourself. We'd love to challenge this tool. I know I've been wrong a couple times with it. I used to always say phosphorus is the number one thing that you have to fix. Well, no, it's not. Sometimes it is pH. Sometimes it is potash. And sometimes it's boron. What a cool tool. Give us a shout. Let us show you how it works. Thanks very much.